Welcome everybody to Euclid's proposition number 5. So in this proposition we are asked to show that in an isosceles triangle the angles at the base are going to be equal to one another, and furthermore if the equal straight lines were extended and produced further, the angles under the base would be equal as well. So let's take a look and see why this is going to be true. Well, we need to start off with an isosceles triangle. For that, we can start off with a side, say, between 2 points, A and B. Now, what we want is this to be, we need another side that's going to be congruent to this side AB. And so what we can do is to just draw the circle centered at A and passing through B, and then we just choose any other point on that circle. Now, when we do this, we end up with our segment AC. From the definition of a circle, we know that segment AB is going to be congruent to segment AC. And so we know that those two are going to be the same. So we don't really need that circle anymore, so we can get rid of that. And we can complete our triangle to get our segment BC. So now we have an isosceles triangle. All we are assuming is that two sides of that isosceles triangle are going to be congruent. Now we know from postulate 2 that we are able to extend these line segments AB and AC further to become rays. So if we do that, we get something that looks like this. Now what we want to do is to choose a point D on one of those rays. So what we want to do from here then is to get a line segment that's going to be congruent to this line segment AD. Well, again, using postulate 3, we can draw a circle that's centered at A and passing through D. Now that circle is going to give us an intersection point with our ray AC over here at point E. Now from our definition of a circle, we know that AD is going to be congruent to AE. And so because we had that AB was going to be congruent to AC, if we remove AB from our segment AD, and if we remove AC from our segment AE, then what that gives us is that our remaining segments BD and CE are going to be congruent by our common notion 3. And so at this point we can get rid of our rays and we can get rid of our circles that we don't need that one anymore. Now what we want to do is to throw in a couple of new line segments. So we want to draw our line segment BE, and we want to draw in our line segment CD. Now what this allows us to do is to consider a couple of triangles. First triangle we're going to take a look at is triangle ACD, and the second triangle we're going to look at is triangle ABE. Now, we know that in our blue triangle, side AE is going to be congruent to side AD in our red triangle. We also know that side AB in the blue triangle is going to be congruent to side AC in our red triangle. And since those two triangles have the angle at A in common, what that tells us is that these two triangles are actually going to be congruent by our side angle side congruence property, or what we did in proposition number 4. Now in particular what that means is that our third sides here, DC, is going to be congruent to our third side in the blue triangle of BE. And so also what that means is that our corresponding angles here, our angle CDA, is going to be congruent to our angle AEB. And so if we plot each one of those, then we see that yes, those two angles are going to be congruent as well. Now we're done with those two triangles, so let's turn off our red triangle and turn off our blue triangle, and let's now look at a couple of other triangles. So what we're going to be interested in this case is triangle BCD and our triangle BCE. Now what we have in each one of these triangles is that we can see that we have two sides that are going to be congruent. So side BE is going to be congruent to side DC, and our sides CE is going to be congruent to our sides BD, and we also know that our angles out here at E and D are also going to be congruent as well. And so one more time, by our side angle side congruence theorem, our proposition number 4, we know that our triangles BCD and BCE are going to be congruent as well. Now in particular, this means that for a couple of the angles, our angle BCE and our angle DBC, those are going to be congruent as well because they correspond in our congruent triangles. And so this actually gives us kind of the second part of our proposition, where it says if the lines were to be produced further, the angles under the bases are going to be equal. That's exactly what we have here. We have that our angle BCE is going to be congruent to our angle DBC. Now, kind of for our very last step, we know that we can see that we've got straight angles here at DBA and here at ACE. Well, because we know that our angle BCE and DBC are going to be congruent, if we remove those angles from our straight angles, what happens is that we have angle ACB and we have angle CBA that are going to be congruent, and that follows from our common notion 3. And so this gets us our very final conclusion that the angles at the bases of an isosceles triangle will be congruent to one another, as was to be demonstrated. So I hope you guys have enjoyed this, and I will see you guys in the next proposition. Take care.